In this mini clip, we will be solving trigonometric equations. While we answer this question together, you will be solving the similar problem on your own using the same technique. We are asked to solve for x, where the equation given to us is 6 times cos of 2x plus 10 equal to 7, and our x is bounded from 0 to 2 pi. To answer this question, we're first going to isolate for cos of 2x. I'm going to rewrite this equation here. Isolating for cos of 2x, I'm going to bring this 10 to the other side of the equation. So we will have 6 times cos of 2x is equal to 7. Bringing this 10 to the other side makes it negative. So 7 minus 10. This is equal to negative 3. So our next line will be 6 times cos of 2x is equal to negative 3. Now we need to get rid of this 6. The operation here is multiplication. So to get rid of the 6, we need to divide both sides of our equation by 6, since division is the opposite operation of multiplication. 6 divided by 6 will give us 1, so these cancel out. And we are left with cos of 2x equal to, now we're going to write this fraction in simplest form. We can divide both the numerator and the denominator by 3. Negative 3 divided by 3 give us negative 1. 6 divided by 3 will give us 2. I would now like you to isolate for sine of 3x in the question that you are given. This is the answer you should have got. Coming back to our question, you'll realize that the trigonometric ratio for cos of 2x, negative 1 over 2, is in fact negative. This is going to help us determine which quadrant our angle 2x will be found in. So here we have our quadrant plane. Remembering our cast rule, CAST, the trigonometric ratio for a cos function will be negative in quadrants 2 or 3. This is because in our second quadrant, the S indicates that the trigonometric ratio for only the sine function will be positive. That means that the trigonometric ratio for both cos and tan are negative. And this is exactly what we have, a negative trigonometric ratio for cos. In the third quadrant, we have a similar argument. The trigonometric ratio for a tan function is positive, so our sine and cos functions will have a negative trigonometric ratio. In quadrants 1 and 4, our trigonometric ratio for cosine would be positive. This is why we're not going to consider these quadrants. I'm going to now draw the terminal arms in quadrants 2 and 3, since these are the two quadrants we are going to consider. The theta represents the angle of 2x. So looking at our second quadrant, I'm going to draw a right angle triangle. I'm going to do this by just drawing a line from the end of our terminal arm to the x-axis. Because this is a right angle triangle, we are going to use SOHCAHTOA to help us solve our question. According to SOHCAHTOA, the trigonometric ratio for a cosine function, the c, is adjacent over the hypotenuse. So here we have our trigonometric ratio for cosine. We know that it's going to be the adjacent side ADJ over the hypotenuse. Looking at our right angle triangle, cos of our angle would be adjacent, which is this side, over hypotenuse, which is this side. We know our adjacent is equal to 1. I'm going to ignore this negative. And our hypotenuse is equal to 2. This triangle should now be familiar to you, since it is one of our special triangles. The other side will be equal to the square root of 3. And this theta will be equal to pi over 3. This angle here. And this angle up here will be pi over 6. I'm just going to draw it a little bit neater. Pi over 6. I would now like you to draw the quadrant plane along with the corresponding triangles for the question that you were given. Here's how your diagram should look. Now coming back to our question, we actually found that theta is equal to pi over 3, this angle here. Now remember, our theta represented 2x. But this is our related acute angle. We need to find the principal angle of pi over 3 here. The principal angle starts along this x-axis here, this quadrant, and it moves in the counterclockwise direction to this terminal arm. To determine the measure of this angle, we're going to subtract pi over 3 from pi, which is the angle of a straight line. Again, we have this angle of a straight line, which is pi. Subtract from pi over 3 will give us this angle outlined in red. When we do this subtraction, we will actually find that this angle will be 2 pi over 3. So our 2x is actually equal to 2 pi over 3. This is our first angle. So I'm going to write 2x is equal to 2 pi over 3. Now we need to solve for our second angle when we're in the third quadrant. Again, this angle starts along here and comes all the way around to this terminal arm because we want to look for the principal angle. This is the angle we want to use. I'll outline this angle in green. So we'll start here, we'll come all the way around to here. And this will be our second angle. To determine the measure of this angle, we know that the angle of a straight line is pi, which is this angle, and we need to add this theta, which in fact is pi over 3. So to find the measure of this angle, we're going to add pi and pi by 3 together. The answer to this is 4 pi over 3. So this is our second angle. So we can write that 2x is also equal to 4 pi over 3. Lastly, we need to isolate for x, which means that we need to get rid of this 2. To do that, we're going to divide the left-hand side of our equation by 2 along with the right-hand side. So we have that x is equal to 2 pi over 3 divided by 2 is 2 pi over 6. 4 pi over 3 divided by 2 is 4 pi over 6. And this is our final answer. I would now like you to finish off the question that you were working on. And here's your final answer.